In the vast, rust-colored expanse of Mars, the search for life has always been a tantalizing quest, one that has captivated scientists and dreamers alike for generations. For decades, Mars has been the focus of robotic exploration, each mission peeling back layers of mystery to reveal a history marked by water, volcanic eruptions, and the relentless forces of nature. But in July 2024, a discovery made by NASA's Perseverance rover in Jezero crater may have brought us closer than ever to answering the age-old question, did life ever exist on Mars? At the heart of this groundbreaking moment lies a rock known as Chayava Falls. Unlike the red dust and barren stones that dominate the Martian landscape, Chayava Falls is special. It was formed between 3.2 and 3.8 billion years ago, during a time when Mars may have been much more Earth-like, a world with lakes, rivers, and the essential ingredients for life. Perseverance carefully drilled into this ancient lake bed, extracting a sample that scientists have dubbed Sapphire Canyon. What they found inside has electrified the scientific world, a collection of minerals and organic compounds that might be the long-awaited fingerprints of ancient Martian life. One of the most intriguing findings in Sapphire Canyon is the presence of a greenish mineral called vivianite. On Earth, vivianite is often found in environments shaped by microbial activity. It forms in places where life is abundant, swamps, lake beds, and even within the bones of ancient animals. Its vibrant green hue is not just a feast for the eyes, it's a clue, a suggestion that biological processes may have played a role in its creation. Alongside vivianite, Perseverance detected greigite, another mineral closely associated with microbes here on Earth. Greigite forms in sediments where bacteria thrive, often as a byproduct of their metabolic activities. But perhaps most remarkable is what these minerals are telling us. The coexistence of vivianite and greigite in a Martian rock is not easily explained by simple chemistry alone. On Earth, such minerals rarely form together unless life is involved. Their presence, coupled with organic carbon, the building blocks of all known life, suggests that the conditions in Jezero crater billions of years ago might have been ripe for microbial communities. These aren't just ordinary rocks. They could be biosignatures, traces left behind by life itself. To understand the significance of this discovery, we must journey back in time to when Mars was a young planet. Over 3 billion years ago, Jezero crater was not the dry, wind-blasted basin we see today. It was a lake, fed by rivers and perhaps teeming with life. The sediments that settled on its floor preserved a record of whatever existed there, a geological diary written in stone. As the planet cooled and its atmosphere thinned, water evaporated and the crater dried up. But the clues remained, locked away in the mineral veins and pockets of organic material. For years, scientists have searched for evidence of Martian life, knowing that any proof would likely be ancient, dead for billions of years, if it ever existed at all. Previous missions, including the Curiosity rover, have uncovered tantalizing hints: ancient organic molecules, mysterious methane variations, and structures that resemble fossilized microbial mats. Each discovery has added another piece to the puzzle, but none as compelling as the recent findings in Sapphire Canyon. What makes these biosignatures so important is not just their existence, but what they represent. On Earth, vivianite and greigite are more than just minerals. They are markers of life's handiwork. In swamps and lake beds, microbes interact with iron and sulfur, transforming them into these distinctive crystals. The process requires water, energy, and the complex chemistry of living organisms. To find these minerals together in a Martian rock raises a profound possibility. Perhaps in the distant past, Mars was not a lifeless world, but a planet alive with microscopic inhabitants. Yet the excitement is tempered by caution. Science demands proof, and minerals like vivianite and greigite can also form through non-biological processes. Volcanic activity, chemical reactions, and even the slow movement of groundwater can create similar structures without any help from living creatures. The challenge lies in distinguishing between these natural processes and those driven by life. It's a mystery that will require years of careful study, advanced laboratory analysis, and perhaps even the return of Martian samples to Earth. The Perseverance team is acutely aware of these challenges. As they continue to analyze the data, they are looking for patterns, chemical signatures, isotopic ratios, and microscopic structures that cannot be explained by geology alone. They are searching for the unmistakable hallmarks of biology, complex organic molecules, cell-like shapes, and mineral layers that mirror those found in ancient life on Earth. Every detail is scrutinized, every anomaly investigated, because the stakes are nothing short of cosmic. If confirmed, these biosignatures could revolutionize our understanding of life in the universe. They would show that life is not unique to Earth, but a phenomenon that emerges wherever conditions allow. It would mean that, billions of years ago, Mars was a world with lakes, rivers, and living things. Perhaps not sophisticated creatures, but simple microbes, quietly shaping the planet's history. The implications are staggering. If life could begin on Mars, it might exist elsewhere, on the icy moons of Jupiter and Saturn, on exoplanets circling distant stars, or even in the hidden corners of our own solar system. This discovery also casts new light on the origin of life on Earth. Did life arise here independently, or was it seeded from Mars or another world? The similarities between Martian and terrestrial minerals suggest common processes, shared chemistry, and perhaps even a deep cosmic connection between planets. The search for Martian biosignatures is, in a sense, a search for our own beginnings, a quest to understand how life arises, evolves, and endures across the universe. As NASA continues its mission, the Perseverance rover is more than a machine. It is an ambassador, a scientist, and a storyteller. It carries the hopes of millions, probing the ancient rocks, seeking answers to questions older than humanity itself. Each sample it collects is a treasure, a fragment of another world, and in the case of Sapphire Canyon, perhaps a relic of long-dead Martians, organisms that lived and died in the cradle of Jezero Crater. The journey is far from over. Future missions will build upon these discoveries, sending more advanced rovers, landers, and eventually humans to Mars. The goal is to retrieve samples, bring them back to Earth, and subject them to the full power of our laboratories. Only then can we hope to unravel the secrets locked within Vivianite and Greigite, to read the ancient diary of Mars and discover if life truly once flourished on the Red Planet. In the meantime, the scientific community is abuzz with excitement and debate. The findings published in Nature have sparked new research, collaborations, and theories. Some scientists argue that the evidence is strong, too strong to ignore. Others urge caution, noting the many ways minerals can form without biological input. This is the essence of science: curiosity, skepticism, and the relentless pursuit of truth. Beyond the laboratories and mission control rooms, the public too is captivated. The idea of ancient Martians, of life on another world, stirs the imagination and inspires dreams of exploration. It challenges us to look beyond our own planet, to consider what it means to be alive in a universe filled with possibilities. The green crystals of Sapphire Canyon are more than just minerals. They are symbols of hope, reminders that the search for life is a journey worth taking. And so, the question remains: has NASA found 3 billion-year-old dead Martians? The answer, for now, is tantalizingly close, but not yet certain. The presence of potential biosignatures, the green Vivianite, the enigmatic Greigite, the organic carbon, all point to a time when Mars may have been a living world. But definitive proof awaits further study, more samples, and perhaps the sharp eyes of scientists searching for the smallest details. What we do know is this: Mars is a planet with a rich and complex history, shaped by water, chemistry, and possibly life. The discoveries of Perseverance have brought us to the edge of a new frontier, one where the boundaries between geology and biology blur, and where every rock holds a story. The green crystal at the heart of Sapphire Canyon is a beacon, illuminating the path forward and inviting us to continue the search. In the coming years, as new missions are launched and samples returned, we may finally answer the question that has echoed across generations. We may discover not just the remnants of ancient microbes, but the profound truth that life is a cosmic phenomenon, woven into the very fabric of planets and stars. Until then, the search continues, driven by curiosity, guided by science, and inspired by the possibility that we are not alone. The Perseverance rover, standing silent in the windswept crater of Jezero, is more than a robot. It is a witness to history, a collector of secrets, and perhaps the discoverer of Martian life. Its findings hint at a world that once was, at microbes that may have lived and died long before Earth took shape. The green crystal, shimmering in the Martian dust, is a sign, a biosignature, a clue, and a promise. A promise that the universe is vast, mysterious, and filled with wonders waiting to be found.